Good evening to all the grade 12 students. Welcome back, welcome back. Welcome back to one more session of your WOC. This is your Vani ma'am. All right. So, how are you all doing, students? Before we start the video, give me a smiley. Yes. Keep smiling, students. Nothing is going to happen. Give me a smile. Be happy always. Your smile matters a lot to us. Yes. How much ever bigger smile you give me, that looks more and more wonderful, isn't it? So, hello, namaskaram, vanakkam, shasriyakal, adabad say everybody, whoever, bonnara, channagidra, welcome back. Today in the series, as I said, we are doing board preparation. Till now, we have done solutions, haloalkanes, electrochemistry, D and F block. Now we are doing alcohols, phenols. Nothing to worry. As I said, join the Telegram because I'll be sending loads and loads of notes. Today we are going to study the most important part of your alcohols, phenols, and ethers. Yesterday, what did I do? I have sent 250 MCQs for your chapter, right? Where did I send? I have sent into your Telegram channel. I have sent this in the Telegram channel. Now, I'm going to do today in this video nomenclature, name reactions. Here again, it is repeated name reaction, important name reactions. So, few are there like oxidation and all those we don't call, but they come under the name reactions. Distinguishing test, conversions, word problem, reason based questions, mechanisms, everything I'm going to cover today. So stay connected, watch the video till the end. Wherever it is required, wherever it is done, everything I'm going to explain clearly. Let's start the video. All the best. Once again, give me a smile, students, and that gives me tons of energy. Yes, tons and tons of energy. Let's start. So, different varieties of questions. So, I'm going to start with the 2 marks questions. Watch carefully till the end. With this, everything will be completed from your alcohols. Let us read the first question. There are two questions here. This is question number 1 and this is question number 2. Easy question. Read the question. Give two reactions that show acidic nature of phenol. Compare acidity of phenol with that of ethanol. So they are asking us to give two reactions which gives acidic nature. So normally students, acid, when do we call acid? A particular substance or any particular compound, if it reacts with a metal, if it releases hydrogen gas, then I call it as acid. Correct, right? The same thing. I'm going to take phenol. Okay, one reaction. Then what will I do? I will react with a highly reactive metal, that is sodium. Metal plus a particular compound. If it is acid, because they're showing to acid, so now in this case, phenol is acting as an acid. What will happen? This bond breaks here. This sodium goes and attacks. What will I get? I will be getting a compound that is nothing but sodium phenoxide, ONA. What is released out? Hydrogen. Only half hydrogen is there. So I'll be getting half hydrogen gas in this case. Correct, right? Over. So now, because hydrogen gas is released here, I can clearly say that phenol is acidic in nature because of release of hydrogen. You can just write this reaction because they asked me to give reaction. I have written that. That is over. They said, give me one more reaction. What is the other reaction which I can give? So phenol, see here again, one more neutralization reaction, phenol. Okay, I'm taking, now I'm telling this is acidic in nature. This is acidic. So I'm going to add one base to this. Base, sodium hydroxide, I'm adding a base. So this is nothing but acid plus base gives me salt plus water. Shall we write water first? We will write water. What is a salt formed? Same thing. There is a cleavage here. O, there is a cleavage here. You'll be getting sodium phenoxide. So see carefully, both the reactions, this is salt, this is plus water. So this is acid plus base gives me salt and water, shows that phenol is acidic in nature. So these two are the reactions. Now they asked me compare acidity of a phenol with that of ethanol. Okay, so first of all, phenol and ethanol. First, acidic phenol. Why is it more acidic than ethanol? Let me write. Phenol, according to my this one, phenol is more acidic than ethanol. What is the reason? Simple reason. Because phenol, what happens? It shows resonance. Correct. Phenol shows resonance. So what is happening whenever phenol, after it starts giving that, so I have to write in this terms. This is because of losing a proton. First of all, you will start writing phenol is more acidic than ethanol because, let me write the answer, then you can, because after, you can write exactly like this in the exam, after losing a proton. Okay, after losing a proton, release of proton is nothing but acidic nature, no? Yes, the phenoxide ion, the phenoxide ion undergoes, what does it undergo? It undergoes resonance. It undergoes resonance, yes, and gets stabilized and gets stabilized. Yes or no? Gets stabilized. So stabilized. So what happens? This whatever phenoxide ion is there, just see here. I'm going to take one phenoxide ion. I've already it has released the proton. Okay, this is oxygen atom. How many? One, two, three, four, five, six. Now this is released, no? Exactly, this goes, see, this shifts here, like that. It shows a series of resonating structures. So these series of resonating structures, shall I show you? So this donates the particular electron, so this becomes double bond, your oxygen atom in this way, like that. You can show your, so this is already gone, right? This electron is already gone, right? So this particular ion, in that way you're going to show the resonating structure. This shifts here, like that. You're going to show a series of resonating structures. Gradually this double bond is here only, nothing to disturb. So when this bond shifts here, you have here, you have again have a minus, then again double bond. This double bond shifts here, again you have a resonating structure. This goes, this is again here, this one, this bond shifts here, isn't it? So gradually you're going to show all the resonating structures, and finally this bond shifts, this goes here, and finally you'll be getting a resonance hybrid, or completely resonating structure resonance hybrid, where all the pi bonds are satisfied, and this becomes, oxygen becomes single bond with one, two, three, four, five, six minus. So this is how you're going to say. But in ethanol, is there any resonance, students? So you'll write ethoxide, you'll put a star here. Ethoxide does not show resonance. That's all. Does not show resonance. Hence, it is hence with above factors, factors, phenol is more acidic than ethanol. That's all. You'll just write the answer like this and leave it. You'll be getting complete marks in that. Is it okay? Is it clear, students? Okay. So one more question is there. How does phenol react with bromine in CS2 and bromine water? So I am going to leave this to you, students. Can you tell me this answer in the comment section? Bromine and carbon disulfide and bromine water? Tell me. I'll give you that space. What is that? You're going to give me in the comment section this answer. Let me tell you, whoever gives me the answer, that particular first comment will be pinned. First comment. Whoever gives me the first answer or first comment, that answer will be pinned. So what is the question? They asked me, what are the products formed when your phenol is going to react? Easy question, just for you to test. Reacts your phenol reacts with bromine in carbon disulfide and bromine water. What are the two products you're going to tell me in the comment section? I'm going to pin it. I'm putting a question mark. Answer this. Is it easy? Easy. Sure. Next first comment will be pinned. Next question, let us see the next question, students. Next question is this question. Explain the mechanism of dehydration of ethanol. So mechanisms are very important. In the previous video, I have given you the mechanism for the dehydration. So here I have given you, because for us to faster to study quicker. So mechanisms, I also did this mechanism in detail in one short video. In one short video, I have already explained one short video in detail explanation. Please watch that. So exactly, it is an NCRT mechanism. I have taken it. Yeah. Let us see the next question. Give one chemical test to distinguish between the following pairs: phenol and benzoic acid, one propanol and two propanol. Oh, easy question. So first of all, phenol and benzoic acid. I'll simply give you the solution, students. Easy. Suppose if you have phenol and you have benzoic acid. Now, normally acid, what is the thing, students? It is COOH, right? COOH. So does it release carbon dioxide? Yes, it releases. So simple question. Just remember, phenol, when I add acid, this is what you should remember. When you add sodium hydroxide, sodium bicarbonate to phenol, what does it do? Does it have any COOH group? Yes, no COH group. So phenol will not react. This one will rule out. When it is benzoic acid, what will happen? C6H5COH. Now you see here there is COH group. So what will it do? It will give brisk effervescence. The brisk effervescence means what? It is going to release. Brisk effervescence is nothing but it is going to release carbon dioxide gas or carbon dioxide bubbles. So I can easily differentiate both of them. Easy, easy. Next question. What is other thing? They asked me one propanol and two propanol. Okay, second question. Let us write one propanol. This is what? This is OL. Then it is two propanol. Correct? Now you see. This one propanol and two propanol. Shall we write the thing? 1, 2, 3, 4. Okay. 1, 2, and this is 2 propanol. Now you only see students 2 propanol. Careful. You remember iodoform test? Ketones or methyl ketones, 2 propanol groups. These, see here, this is CH3 group, right? This is also CH3 group. So, methyl group attached to the secondary carbon, that also gives iodoform. So, simple write down, when we add iodine to this, which one? First one. So, iodine, and what is the other thing with iodoform? And sodium hydroxide. What will happen here? Draw a line here. And you add iodine to iodine and sodium hydroxide. This is your iodoform test. What will happen in case of one propanol? There is no reaction. Now, in case of 2 propanol, what will it give? It's going to give an yellow PPT of iodoform, correct? Na? Yellow PPT of iodoform is formed. With that, I can differentiate, isn't it? Yellow PPT of iodoform. This is what it gives. So, clear? 1 propanol does not give, 2 propanol gives. Easy question? Very easy question. Let us see one more. Name the reagents used for the following reactions. Okay. First, bromination of phenol to 2,4,6 tribromophenol. So, I will write the first one. So, remember, reagents are also very important in organic chemistry. Which one gives you? I already gave the answer. Okay. Anyways, bromine water. Bromine water is used to convert or to brominate to get 2,4,6. If you want individual products, then you use bromine and carbon disulfide. Correct? Bromine water, nothing but aqueous. So bromine water is nothing but aqueous. You can write like this, or you can write bromine aqueous. First is done. Next question. Butane 2-on to butane 1-ol. Okay. So this is what students, ketone. Ketone, right? 1, 2, butane 2-on, 3, 4. Correct? Butane 2-on to butane 2-ol. 1, 2, 3, all. Now you only tell me this is ketone, this is alcohol. What is the difference between both of them? There is one hydrogen which is added. So which one will add? You will be getting reducing agents like lithium aluminum hydride is one reducing agent. Hydrogen in the presence of nickel is one more reducing agent. So these two will convert or add hydrogen. That's nothing but reduction. Next, Friedel-Crafts alkylation of anisole, they said. Friedel-Crafts alkylation. Alkylation, what is the reagent, students? Alkylating agent is nothing but methyl chloride and Lewis acid AlCl. We just write the reagents. So this Lewis acid is nothing but anhydrous. This anhydrous condition is very important. What is the fourth question they asked me? They said oxidation of primary alcohol to carboxylic acid. Okay, primary alcohol. Okay, so did they give me anything? They didn't give me anything, only alcohol to acid they gave me. So 1 degree alcohol, okay, to what they give me? Carboxylic acid. To carboxylic acid. What is the difference between 1 degree alcohol and carboxylic acids? Yes, then just check. Alcohol, this is OH group. This is acid, COH group. What is added extra? It is nothing but your oxygen is added. Correct, na? Yes. So oxygen is added. What is the oxidizing agent you're going to use? You're going to use KMnO4. Yes. And you're going also going to use H3O plus. So the oxidizing agents convert primary alcohols to acids. Is it easy? Easy? Easy. So that is how it goes. Question, reagents are easy. Next question, students. How will you convert the following? Okay, they asked me to convert to propan to ol to propanone. Propan to ol to propanone. Easy. First of all, let us write the structure. Propan to ol. This is your propan to ol. I have to convert to propanone. Okay, CH3 CO double. Now you only see the difference, students. Between this and this, what is the difference? Here there is hydrogen, here there is no hydrogen. So what is the reagent which removes hydrogen? See, we studied a reaction, right? Addition of oxygen or removal of hydrogen. Okay, yes. Copper. Copper at 573 Kelvin does this work for us. It's going to remove hydrogen and converts secondary alcohols to ketones. Done. Next question. Do I have place next page? Yes, I'll do it next page. Phenol to 246 tribromophenol. Okay, easy. Phenol, they're asking me to convert to 246 tribromophenol. Okay, done. Let me write the product both the sides. This is OH. They're asking me to convert to 246 tribromophenol. Okay, done. What is extra? Three bromines are extra. So can I add aqueous bromine or bromine water? Yes, bromine water gives us the final product. Carbon disulfide, it selectively gives us the product, but it is 246, it is aqueous bromine, so it adds directly to this. Easy question. Let's see the next question. Next. Give a separate chemical test to distinguish between the following pairs of compounds. Ethanol to phenol, 2-pentanol to and 2-pentanol and 3-pentanol. Okay, let me do the first one. Ethanol, this is alcohol, this is alkyl group, this is aromatic ring, this is aliphatic ring, this is aromatic ring. Now tell me students, in the differentiation test, when you do between alcohols and acids, there is effervescence. But when you do between aliphatic alcohol and aromatic alcohol, the best test is neutral FeCl3 test, students. Neutral FeCl3. Remember, whenever one aliphatic and aromatic is given to you, aromatic alcohol and aliphatic alcohol is given to you, one test is neutral FeCl3. What happens in case of ethanol when you add a neutral FeCl3? This one, when you add, there is no reaction. Yes, but when it comes to phenol, when you add neutral FeCl3, violet coloration is observed. Violet coloration is observed in this. So I can easily prove that. Best test, students. Easiest test. Neutral FeCl3 between aliphatic and aromatic. Now you see here, 2-pentanol and 3-pentanone. Okay, they have given me one alcohol and one ketone. So what is the best test to convert uh, alcohol and ketones? But here ketones, when you get, no, see here, is it methyl ketone you see once? Yes, let us see. 2-pentanol and 2 3. Okay, let us write first. 1 2 3 4 5. What is it? It is 2-pentanol. Okay, 2-pentanol. See here, CH3 group. Done. What is the other one? We have got 3-pentanone. 1, 2, 3. This is 3. This is pentanone. This is not CH3 group, correct? This is your CH2 group. CH2 group. So, you only tell me, students, when you find such group, compulsory gives me iodoform test. Iodoform test, this is what it gives. Iodoform means you're going to add iodine and sodium hydroxide. So what happens? What is the color you get? You get yellow PPT. Yellow PPT. That's why this test is confirmed. In this case, does it give anything? No. No reaction. No reaction with iodoform. So with this, I can differentiate both of them, right? I can differentiate both of them. Simple. Next question. Arrange the following compounds in the increasing order of their acidic strength. Okay. Paracrysol, paranitrophenol, phenol. Oh, acidic strength, as you all know, more the electron withdrawing group, more is the acidity. Correct? So this is paracrysol, the methyl group which you have. Okay, phenol. So first comes, let us write this first, this one, paracrysol. More, this will be less acidic than phenol. And here you have an electron withdrawing group. So this is your electron withdrawing group. That's why this is more acidic. This is because of the electron withdrawing group. More acidic. Next question. Write the mechanism using curved notation of the following reaction. Curved notation means what? I'll tell you what it is. Simple. See here. Next question. What did they give me? They have given me alkene. Take this alkene. So curved notation means this is your alkene. Correct. Now what they're adding? They're adding hydronium ion. So can I write hydronium ion as H, hydrogen, oxygen, hydrogen here? And the bonds, this, done. So 1, 2, 3, 4, 5, 6. All right. Now see here. See this. What is curve notation? First of all, the double bond from here, because oxygen requires a positive charge. Oxygen requires the particular thing. Okay, see here, let us put this arrow here because the bond it requires, right? So from here, just check your student, this is your curve notation. So what happens when you're donating the particular bond or the pi bond electron, get an condition where this carbon is here, one hydrogen, one more hydrogen, one, and because it has lost that bond, right? What else is left out? This bond breaks here, gives here, and you get water molecule with 1, 2, here. They have given me this. They have already given me this CH3. I have copied. But only thing is they're asking you to show this curved notation. So curved notation, let me clearly write it so that it is easy for you all. I'll again show you that curved notation. From here, the bond is shifted here and this one like this. You're able to see, students? You're able to see? This is a double, this arrow, this is curve notation. You're going to show that. That's all. Simple. For this only you'll get mark. Next question. Next question. Well, write the mechanism of the following reaction. Okay. So what is the following the reaction? Okay. First of all, let me give you that. So normally in alcohols, phenols, and this one, uh, there is one, that is dehydration is what you learn. Correct. There is one more reaction which is not given, but you should understand that reaction. I'll tell you because this is very important and typical. That's nothing but, see here. Learn this mechanism directly from here, students. Hydrogen, first of all, HBr is there. HBr, it's going to break up into H plus ion plus Br minus ion. Correct? Okay. So now what are you going to do? You're going to take one alcohol. Oxygen 1, 2, 3, 4 and hydrogen. Then next, you're going to protonate this. So when you protonate this, this goes and adds here. Correct? What do you get? Get what is this called? This is called ethyl, two carbon atoms, oxonium ion. Ethyl oxonium ion. What is this called? This is called a protonated primary alcohol. Protonated primary alcohol. Okay. Right. Now this protonated primary alcohol further when we take, do I have a page? I don't have place. I'll take this. This protonated, when you further cleave it, it will break up into ethyl cation plus one. This ethyl cation, when you're adding bromine, this bromine is there, right? Yes, that bromine you'll be getting ethyl bromide. What is this reaction? So basically nothing, students. They're going to ask you simple. They'll just ask you, how do you convert alcohol to alkyl halide using this mechanism? They'll ask you using the protonation of alcohols. Can you write a reaction? Okay. So when they ask you protonation of alcohols using reaction, uh, then you can just write this completely set of reactions. And next question. Explain the behaviors, explain the following behaviors. Alcohols are more soluble in water than hydrocarbons of comparable molecular mass. Okay, I have a place here. I'll just do this. First question I'll make here. Alcohols are more soluble in water. First of all, to get soluble in water, what is required, students? Hydrogen bond. Alcohols form hydrogen bonds. Correct? Yes. Compared to compared to compared to hydrocarbons. Correct? Compared to hydrocarbons, they form hydrogen bonds of compare hydrogen. That's all. You write this is enough. It is understood. Hence soluble. Hence alcohols are soluble. This is done. This will do. Okay. Next question. Orthonitrophenol is more acidic than orthomethoxyphenol. Okay. First of all, in orthonitrophenol, what is there? Minus, that is NO2 group. Correct? NO2 group is electron withdrawing group in case of orthonitrophenol. Correct, na? This is electron withdrawing group. Now, because of this electron withdrawing group, what will happen? The stability of the phenoxide ion, whatever is there when the negative charge is dispersed in the particular ring, it will try to, this NO2 will increase the stability of phenoxide ion. You have seen the resonating structures, right? So how do I write this answer? The NO2 group, electron withdrawing group in case of orthonitrophenol increases stability of phenoxide ion. Phenoxide ion. Correct? By dispersal of negative charge. This is what you will write. And you don't write any resonating structures. But in case of but in case of second one is there orthomethoxyphenol OCH3 group. What is this? This is electron releasing group. So because of this, what will it do? In case of in case of OCH3 in orthomethoxyphenol, what will it do? It's going to reduce or decrease acidic strength. Why? It's going to decrease, you'll write, let us write this. But in case of OCH3, electron releasing group in orthomethoxyphenol, decreases acidic strength, of phenol by destabilizing, the phenoxide ion, by destabilizing the phenoxide ion. Okay, by concentrating the negative charge. By concentrating negative charge. So that is why orthonitrophenol is more acidic than orthomethoxyphenol. So just you write this one, it will disperse the negative charge, it will concentrate the negative charge. See here, it will concentrate. So because there is no dispersal, because if it is dispersal, it can easily pull the electron density and release the proton. Correct? So, and send an important thing is it will also rotate in the ring. Correct, na? So both the reasons you can write like this and you will get full marks. That is next question. How do you convert propene to propanol? Okay, propene to propanol. First one, let us do. Propene, CH3, CH2, double bond CH2 plus HB. Correct? Okay. They asked me to form what? Propanol. Let me write that propanol here. CH3, CH2, CH2, CH2 and OH. Okay. Now you tell me, students, what is extra? OH is added. Correct? Now only tell me this is unsymmetrical alkane. Okay. To add this OH, simple. This is a nucleophile. First of all, easy thing is first add this bromine, break this bond, okay, in the presence of peroxide. Use peroxide. I'll tell you why. When you break this bond, see, in terms of peroxide, one product, one alkyl product is more stable, right? Correct? So this bromine goes and adds to this. What will you get? CH3, CH2, CH2Br. From here, I have to add OH. How will I add? I will use aqueous KOH. And I heat it. When I heat it, I'll automatically get the, because OH is here, I'm also going to add Br using anti-Markovnikov addition. What is the next one? They asked me ethanol to propan to all. Next question. Ethanol. Okay, let me write first. This is ethanol. Ethanol to propan to all. Propan to all. This is right? Yes. Now you only see me. What is the difference between this one and this one? There's an addition of OH group here. And there's addition of alkyl group here. Which one will come and add? Grignard's reagent. So Grignard's reagent I am going to take. When I take the Grignard's reagent, yes, you will get a addition product where OMgI forms here and CH3 group. Easy. What will I do? I have to take out that magnesium iodide. I am going to do hydrolysis to this. When I do hydrolysis, what does it do? MgOHI comes out and this bond breaks and the remaining OH, so it comes like this. MgOHI, hydrogen, no, the particular OH comes from water and the H comes here. So over. Simple. Next question. How are the following conversions carried out? Benzyl chloride to benzyl alcohol. Benzyl chloride to benzyl alcohol. Okay, first of all, chloride. Let us write chloride. Benzyl chloride. Okay, this benzyl chloride. Next is what? Benzyl alcohol. You only see the difference, students, between this one and this one. What is the difference? Cl and this is OH. I have to add OH, nucleophile. Can I use aqueous sodium hydroxide? Simple. Aqueous group, if you use, this nucleophile is replaced by OH. Correct? Next. Methyl magnesium bromide to 2-methyl propan-2-ol. Don't panic. First of all, write the structure. What did they give me? They asked me methyl magnesium bromide. Okay, I'm going to take methyl magnesium bromide. What did they say? Getting converted to 2-methyl propan-2-ol. 2-methyl, let us write. Let me take 2-methyl. Okay, one is 2-methyl propan-2-ol. Propan-2-ol. This is what I have to convert. Now tell me, already one CH3 is here. Correct na? Among this, the CH3 is here. I have to add this group extra. Correct. And this is formed due to hydrolysis. So what will I do? I will add this group, whatever is there extra from here. So what will I do? I will add a group with 3 carbon atoms, okay, and it will be a ketone. Why did I take ketone? I said na, when you add Grignard's reagent, hydrolysis, you get this product. That's why. So when I add this, what do I get? I get a compound which is nothing but OMgBr plus or CH3 and a CH3. Done. Now further what will I do? I will do hydrolysis to this. To this compound I'm going to do hydrolysis. So this comes out as MgOHBr and C. Very easy. Next question. Next, this is blank, students. Already I did. This is the blank page. Next question. Explain the following each for each. Okay. So Kolb's reaction, name reaction, very important. What is Kolb's? Kolb's is going to convert. Kolb's reaction is nothing but simple reaction. We will do it simply. Kolb's is going to convert phenol to salicylic acid. Phenol to salicylic acid. Once again, Kolb's is going to convert phenol directly into salicylic acid. What is salicylic acid? Same. See here, both are same formulas, OH and OH. What is acid? This is your acid. Okay. So what will convert this to this? First, OH, aqueous NaOH. Acid. What is our next one, students? Carbon dioxide. And that's all. This is salicylic acid. Conversion of this is called easy. Easy. Correct. Now, next one. Same thing for your Riemann-Timmon reaction. What is the difference between this one and this one? You all tell me in the comment section. Will you tell me in the comment section, students? Chalo. Who is going to tell me about the Riemann-Timmon reaction? Mention what is the difference between this and this. That mention it in the comment section. I'll be waiting for your answer. The first comment will be pinned. I think it's the same, not same. Let me tell. Please let me know. Next question. Show how are the following alcohols prepared? How are the following alcohols prepared by the reaction of suitable Grignard's reagent on methanol? Okay. So they're asking, show how are the following alcohols prepared by the suitable reaction on methanol. Okay. What are they asking me is, do I have a page here? Yes, I have one page. I can take that. First, I'll do this here. See, they said you're going to take methanol. Methanol. Then what did I do? I have taken this particular compound. Then they said, how are the following alcohols prepared by the reaction of suitable Grignard's reagent on methanol? Already this is a Grignard's reagent itself. So I should not take alcohol. What should I do? I have to take a Grignard's reagent. So what is a Grignard's reagent? This also let me erase. Okay. First of all, let me erase this. I'll make you understand, students. Okay. Following alcohols. Okay. So I have to start from this alcohol. Write this alcohol here. Complete alcohol. CH3, CH, CH3 and OH. Okay, now you see already in this 4 carbon atoms are there, correct? Already one carbon atom is here. How many carbon atoms should I take here? I have to take only 3 carbon atoms. Because fourth carbon atom is here. Then add this Grignard's reagent to this. Done. So when you add this, same concept, I'm going to add this whole compound. What do I get? I'm going to get CH2. This CH2 is there, right? CH2 and OMGBr. As soon as you get this compound, you're going to do hydrolysis. Once you do hydrolysis, you get the same product what they have told us. Same like this second one also. What should I do? I have to get that. Right? I have to add formaldehyde to this. What product should I get? I have to get this compound. Now you tell me how many carbons are there here. Here, there's one carbon. Already one carbon is there. But what is extra? One ring is extra. So I'm going to take that ring. With which one? With Grignard's reagent. Once I add that particular thing, I'll be getting the complete additive product OMGBr. This is of your formaldehyde. Further, I'm going to do hydrolysis and get what is out of the ring along with that MgOHBr. Correct? Easy, students, very easy. Like that, students. Tomorrow I'll be doing more and more questions. There are a lot of questions. In tomorrow's video, I'll be meeting with arrange the questions, short answer, 3 marks questions. Like that, there are many questions which I'm going to do. Yes, I'll meet you again tomorrow. That the final video for your alcohols. Thank you so much for watching. Please like the video, share the video. I'll be meeting you again tomorrow with the remaining questions. Take care. Keep smiling. Tomorrow I'm going to meet you back with the last part of your alcohols. Take care. Bye bye.